Hello, my name is Angela. My topic of discussion is facial recognition using PCA. First and foremost, let us understand what facial recognition is. Face recognition is the task of identifying an already detected object as a known or an unknown face, and in more advanced cases, telling exactly whose face it is. If you look at the figure here, an image is given as an input, after which the face gets detected. The face detection is identifying an object as a face that is located in the input image. Face recognition decides if the face is someone known or unknown by comparing it with a database of faces in order to validate this input face. Let us look at how facial recognition works. First, an image is captured. Next, the allocations are determined and the image is converted to a grayscale and cropped. The image is then converted to a template used by any search engine for facial comparison results. Now the image is searched and matched using a sophisticated algorithm to compare it with other images in a database. Why I chose PCA for this? Principal component analysis is one of the most effective ways used for the process of face recognition. One of the simplest and most effective PCA approaches used in face recognition systems is eigenface approach. This approach transforms faces into a small set of essential characteristics called eigenfaces, which are the main components of the initial set. The figure shows how PCA recognizes our faces. Here is the breakdown of eigen algorithm. Let us consider an image with 2D array of intensity values. First step is to prepare the training faces. Next, we prepare a data set where each image is transformed into a vector and placed into a training set. Next step, we compute the average face vector. Next, we subtract the average face vector from the original faces and the result is stored. In the next step, we calculate the covariance matrix. Step 6 is to calculate the eigenvectors and eigenvalues of the obtained covariance matrix. Next, we determine only a small part of characteristic features of the faces. Next step is to read the test image and separate face from it. The next step is to calculate the feature vector of the test face. After that, calculation of average distance, which is the Euclidean distance, is done. The final step is to locate the face class with minimum Euclidean distance, which shows similarity to the test image. The complete face recognition process is shown here. For testing the whole database, the faces used in training, testing, and recognition are changed, and the recognition performance is given for whole database. One more advantage with PCA is that it not only recognizes the vertical pose but also identifies the variation pose. In result 1, we see that recognition is done for a vertical pose, whereas in 2, variation is also recognized. Here we can see a few areas where facial recognition is implemented, such as airports, social media, advertising, surveillance, and security. Apart from this, facial recognition is also used in schools, colleges, marketing agency, etc. to name a few. Facial recognition technology has come a long way in the recent years. Today, machines are able to automatically identify information for security tasks, etc. These systems are going to be widespread in the coming generations. Thank you.